Hi, my name is Mahi Labib, and in this video, I'm going to show you the image section of Wolfram Mathematica. So, without doing further, let's get to the screen. So now we are at the screen. To start image processing, we need to first take our current image as an input. To do that, we can just use our laptop's webcam to take current image as an input. After pressing this, Wolfram Mathematica will take your current image from your laptop webcam. So in this case, you can see my image is taken here. Okay, so to go further, we can just so now the first thing we want to do with this image is to color negate this image. To color negate this image, we can just write color negate, copy this image, then paste it over here. So you can see that our negative color image is created here. And the next thing we want to do is blur this image. So now you can see this image is blurred, and we can actually control how much can we blur this image, and then just type the number. So this image is now blurred by a scale of 10. So to keep this video short, I'm just going to skip the typing part of my video. So the next for the next, so I have typed my next function. So what does this function do is after using this function, so we are first taking image that is blurred by the scale of 0, and then after then it's scaled by 5, then 10 by 15. So it's actually creating a table of blurred image, and the image is getting higher by a scale of 5. So our next function is going to collect the images and uh, then present the images in a square shape like this. So this is a blurred image of 0 scale, and then 5 scale, then 10 scale, and then 15 scale. Now I'm going to show you how to get the dominant color of your images. To do that, just type dominant colors and then uh, paste your image. So to get my image, copy image, and then just paste it over here. Okay, so it's taking some time. You can see the dominant color over here is uh, this red color and some black. You can see all the colors that are dominant here. And now what we can do is binarize this image. Binarizing this image is going to convert this image into black and white actually. Binarize, and then, and one another thing, by just not copying and pasting the images again and again, we can use this symbol like this is the output line 18. To get the input from the output line 18, we can just type type this. Okay, and if we paste the image over here, it's also going to give the same result. So you can just use the copy pasting the image, or just typing the numbers by percentage sign before it. And now we want to see the dominant color of our binarized image. So I have typed the function, and if I run it, you can see that the dominant color of a binarized function is binarized image is black and white, and obviously it's going to be black and white because we have just make the image using black and white. And now what we are going to do is edge detect our image. So to that, edge detect, and then put the image over here. So it's going to detect all the image edges of our image. to add two images, I can just write and then paste first image and then this image over here. So image add actually adds the two images, and mm, and, and now we are going to create another function. So I am typing this function inner and then paste the image from here and then type t and t. I've typed the function, and if I run it, you can see it's white. And if I like slide the slider, you can see that the image is binarized by a scale. So yes, I can. When I move the slider, it actually makes the color based on white and black. And one another cool thing to do in Wolfram Mathematica is Wolfram Mathematica can actually detect what is in the image. So if I try to show you that image, just type image, identify, and then paste the image. So Wolfram, uh, so it's taking some time. Okay, so you can see that it can detect this image contains a person. So Wolfram Mathematica uses its artificial intelligence to do that. So now we are going to show some exercises of the image section. Uh, Now you can see the problem. We have to solve this problem. We have to manipulate the interface for blurring an image from 0 to 20. So now I'm starting to solve this problem actually. So I first type manipulate and then blur, blur, get the image from here, here, and let's type T. And we start to and we want to manipulate from T 0 to 20. After typing this, you can see if I slide the slider, you can see that the image is blurring by scale of 0 to 20. And another problem, now I'm going to type this problem. So for the last problem, we have to add an image of its own color negated version and the edge detected version. To do that, we can just write image and then type color negate, type the paste, copy the image from here, and then uh, edge detect. So if I press shift return, you can see that the negative version of my images and the edge detected version of my images have been attached together. And that was basically the image processing section of Wolfram Mathematica. But one another cool thing that I can show you as a bonus is I'm showing you this as a bonus. Okay, so I thought it's cool, and so I thought it would be worth sharing. So if I just type manipulate and then the current image and then the shift return, you can see that the image is actually moving. So manipulating an image actually takes the video, and you can also do this operation by age detecting it or color negating it. So I'm trying to color negate this thing. What can I do is like copy this thing, and then put color negate before it. Color negate. So what it does is it is creating a color negated version of my running video. So I think that was cool, and you can actually use the blur function and the age detection function too. So I hope you enjoyed this section, and we'll see further different sections of Wolfram language in the next videos. Till then, thank you and goodbye. Take care. See you.